let's talk about the IP layer. If we talk about the IP layer, then of course we need to talk about the ping tool. The ping tool can be used to check the IP layer. So I have here my Ubuntu One system, and then I have my Ubuntu 2 system, and for the Ubuntu 2 system I need to reactivate the network. Now that I have reactivated the network, I can simply SSH to this system, SSH Ubuntu 2, and now I have here the Ubuntu 2 system, here the Ubuntu 1 system. So now I want to check if I can reach from this system. Of course, I can try this out. So let's do a ping to the IP address. What's the IP address of the system? IPA. This is the IPv4 address here. So let's check if we can reach the other system. Yes, we can reach the other system. You know how the ping command works. It just sends ICMP echo requests to the target system. Works perfectly here. So my IP layer works, but I only checked my IP connectivity to the local network. I haven't checked the IP connectivity to a remote network. So the second check would be for testing the routing. Can we reach a remote system? Let's try this out with the public DNS server address provided by Google. Ping 8888. And you see I can reach a remote network. So as easy as this, we can check if the routing works. If the routing doesn't work as expected, then we can use a tool called traceroute. I think you may know the tool traceroute or traceRT from a Windows-based system. This is the whole name, the full name for this tool, traceroute. And with traceroute, you can simply follow the path through the network, hop by hop, gateway by gateway to a remote system. So if I call traceroute here, then I see a lot of information about all the gateways on the way from my local system to the target system. So this is DNS. Google system is the last line here. This is traceroute. Traceroute needs to be installed. Traceroute often isn't installed. My Ubuntu 2, I think, doesn't have traceroute installed. Yes, it doesn't have traceroute installed. Okay, so we need to install traceroute, or we can use a different tool. We can use a different tool to check the chain of gateways to a destination. We can use a different tool if we know how traceroute works. How can traceroute know the first gateway? Yes, of course, we can take a look into the route table. IPR gives me the route table, IPR only gives me the route table, and therefore we can know which is the first hop. But how can we know, or how can the traceroute tool know what's the second hop or the third hop or the 10th hop? How can the traceroute find this out? And it's really easy. The traceroute tool sends packets, and every IP packet, no matter what protocol, ICMP or UDP or TCP, every TCP packet has a value within the header called the TTL. It's the time to live. And this isn't a time. Instead, this is an information about or for over how many hops can this packet can be routed. Yeah, so if you send a packet, you have a packet and then you send this packet to a destination. Yeah, then you are here in your local network, then you have a gateway, then you have the next network, and then you have the next gateway, and so on and so on. Yeah? And the idea behind this TTL is that if you have a routing error, so your network points to this gateway points to this gateway, and then perhaps this gateway points back to this one here, then we would have a routing loop. Yeah? And if we send one single packet, yeah, then this packet here would loop forever. Yeah? And to avoid this, yeah, we simply have a TTL. The TTL has a number. A TTL has a number 2. Let's just take the 2 here. Yeah? Then every gateway, yeah, needs to decrease this value by 1. So this gateway gets the packet, yeah, will set a TTL to 1 and send it further. This gateway will then reduce the TTL by 1. The TTL now is 0, and packets with a TTL of 0, yeah, cannot be forwarded. Instead, the gateway will send me a message, an ICMP message, yeah, that the TTL is exceeded. Yeah, and then I know that this here is the second gateway, just because I've sent a packet with a TTL of 2. So the second gateway on the path, yeah, will send me the TTL exceeded. Yeah, and traceroute use this. Yeah, traceroute simply first sends a packet with a TTL of 1, then with a TTL of 2, then of 3, and so on. You see, the fourth gateway here, yeah, doesn't send such an TTL exceeded message, so we do not know the fourth gateway. Yeah, traceroute will send 3 packets, yeah, with every TTL. Yeah, so then it goes further with the 5th, with the 6th, and so on hop. Yeah, and what's the protocol traceroute uses here? Yeah, what's the port? Traceroute uses by default UDP packets, yeah, with a port, with a destination port that's random, with a high random destination port. Therefore, from your enterprise network, perhaps, traceroute won't work, yeah, to the outer internet, often just because your gateways, your firewalls, yeah, will filter the traffic. So we send a packet, yeah, to UDP port 50,000, for instance, yeah, and then this firewall will block the traffic and we won't see any response from a gateway with TTL exceeded. Yeah, so we can solve this if traceroute isn't working in 2 different ways. The first thing is we could use ping for this. Yeah, just add, where is my pen? Here's my pen. Yeah, just add the -t command line switch with a number. And this sets the TTL of the ICMP echo request packet to N. Yeah, so let's try this out. Traceroute is installed. Let's go to the system here. Yeah. Okay, ping 8888. Yeah. Let's terminate this. And you see here we get packets with a TTL of 110. So now let's ping with a different TTL. Let's ping with a TTL of 1. And now you see the first hop on the path responds with TTL exceeded. Yeah, so I sent an ICMP echo request to 8888, and all of a sudden this system here sends me an information the TTL is exceeded. So now I know this is the first gateway on the path. Now let's send a packet with a TTL of 2. This is the second gateway. Yeah. Now let's send a packet with a TTL of 3. This is the third gateway. Now let's send a packet or some packets with a TTL of 4. Yeah. And remember, the fourth hop wasn't discoverable by traceroute, and just because this fourth hop doesn't respond with ICMP error messages here. So let's terminate this. Let's go further with TTL 5, and you see the next hop tells me that the TTL is exceeded. Yeah, and you can, if you want to, automate this, script this. Yeah, we could, for instance, send only one single packet here with dash n1. If we send only one single packet, dash n1 with a TTL of 5. What's wrong? Oh no, not n dash dash c. Yeah, for count, not the number. Yeah, but dash c for counting. So we send only one single packet here. We could now use the grep tool. Yeah, and check for exceeded, for instance, filter for this single line. And now we see this is the 5th hop, and this is the 6th hop, and so on. So now we could go through all the steps, through all the hops, yeah, until we reach the last one here. And the last one here is hop number 13, which is the DNS server itself. Yeah. Okay. So this could be a way to mimic the behavior of traceroute. Yeah. If traceroute isn't available, yeah, or if traceroute doesn't work through your firewall, yeah, and you know that ping is working. Yeah. Not always is ping working. Yeah, sometimes different connections are working. Yeah, for instance, I know from this system here I can reach anything on the internet via TCP port 80, yeah, for HTTP connections, and many traceroute implementations support this, that you can switch from UDP and the random port to TCP and the defined port. Yeah. So if you call traceroute, yeah, to the 8888, for instance, yeah, then you can simply change the port. I want to send UDP packets now to port 80, or I want to send TCP packets to port 80. Yeah, and then if we can connect via TCP or via TCP port 80 to a remote system, yeah, then traceroute would work. Yeah, but if you want to do this, now we need root privileges. So we need to call this via sudo. Yeah, the ping thing, the ping variant, yeah, works without root permissions. Yeah, traceroute with a different port and a different protocol, yeah, needs to be called as root. Yeah, and now we see we can connect to a remote system. We cannot connect to a remote system, but we can send packets to the remote system. Let's terminate this here, and let's shortly explain the behavior we see here. Yeah, we see only the 10th hop here. Yeah, 11, 12, 13 is empty or is not reachable. Yeah, that's just because we have chosen TCP port 80. Yeah, and this DNS server, this Google DNS server, yeah, isn't reachable via TCP port 80. So there is somewhere firewall in place that drops the packets. Yeah, and traceroute cannot see this. It just assumes, oh, the 11th hop here doesn't send a TTL exceeded message, so I go with the 12th and with the number 13 and so on. Yeah. If I do the same here with a system that supports port 80, for instance, google.com, yeah, then we see all the hops again, yeah, to the backend system. This is the system, yeah, that we want to connect to here. Yeah, google.com resolves to this IP address, yeah, just because there isn't now a firewall that filters out these packets. Yeah. Okay, so this is how we could simply check if the IP level works. Yeah, and if the IP level doesn't work, the IP connection doesn't work, yeah, you can simply check via traceroute at which point the connection doesn't work anymore. Yeah, so if I take simply a different IP address, it doesn't exist here, yeah, but simply to check what's the way the packet travels, and then at some point, yeah, you see that it doesn't go further. So we see that we cannot reach this system, yeah, isn't our problem, yeah, but it is the problem on the other side or something in between. Yeah. Okay, so traceroute lets you route the traffic or lets you check the path to a remote system. Often it can be useful to use traceroute here with the -n command line switch, yeah, to avoid resolving IP addresses to DNS names. Yeah, the same with the ping command. Yeah, if you call the ping command here, yeah, and then you can simply add the -n command line switch. Here we do not need a -n command line switch, yeah, but at some point we could add the -n command line switch, yeah, to avoid that this IP address is resolved into a name.